All right, y'all, so this is where it starts to get fun. So this is multi-step factoring. And so basically, what this means is we're going to put all of these together. We're going to put everything together. So here's what we've learned. We've learned greatest common factor. We've learned difference of squares. We've learned sum and difference of cubes. And we've learned trinomial, which is 3 terms. We learned trinomial, guess and check, or trial and error. So sometimes we're going to just do one of these. Sometimes we might do multiple of these. So here's what we're going to do. We're going to always, 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 and I know I keep saying this, we're always going to look for your greatest common factor first. Always. It's going to make it easier. Then decide if it can be factored based on any of the rules of terms. So this is what we have up here. So greatest common factor, we know that this is any. Difference of squares is 2. Difference of cubes is 2. Trinomial is 3. So we're going to look at all of these different terms, and based on the number of terms we have, we're going to know what we can do. Okay? So step 1, greatest common factor. I can pull out a 5, and I'm left with x squared minus 9. Okay, now up till this point we would have said, okay, we pulled out a GCF and we're done. Okay, but that doesn't work anymore. So now this is multi-step. So if I look at this, what I have on the inside right here, what you need to see is that this is a difference of squares. So pulled out the GCF stays. It stays as my answer, but now I have a difference of squares. So I'm going to have x plus 3 and x minus 3. And now it's fully factored. So that would be my final solution. Okay, so if I look at this one, biggest number I can pull out, I guess, is a 3. And so 3 times what? 3 times 4. X squared stays. 3 times 9. Okay, I have 2 terms, perfect square, subtraction. So I'm going to go one more time. Again, this is going to be difference. So 2x plus 3 and 2x minus 3. Okay, number 3 looks funky. We got a lot of things going on, so let's see if we can simplify this out a little bit. So 49 is a perfect square. It's 7 times 7, and 81 is a perfect square, and so I'm not going to be able to pull anything out, but I see I have a b in both of these terms. So my GCF is going to be my b, and I'm left with 49a squared minus 81. Okay, so 2 terms, they're both perfect squares, and I'm subtracting. Now, this is why it was so important in the first few lessons to look for the patterns, because now that we're going to add something to it, you've got to be able to see the pattern. Okay, so when I look at this, I see, okay, this is x cubed, so I think difference of cubes, but this is not x cubed, so it can't be difference of cubes. So I'm going to pull one of these x's out. So I'm going to pull out this x as a factor, and I'm left with 121x squared minus 144. Now I have a difference of squares. So this is a perfect square, subtraction, my difference, and a perfect square. So be careful, because when I first look at this, you're like, okay, well, this is cubed. It's going to be a difference of cubes, but it's not, because this can't be. Plus 121 and 144 aren't cubes anyway. So I have 11x plus 12 and 11x minus 12. Now, what you're seeing as I write these, and this is all super important, is when you pull out your GCF, it has to follow you down. So the GCF has to be part of your final answer. Okay? I'm going to go ahead and pause it, and I'm going to let you finish these last 4. Okay, let's talk through these. Of course, I paused it right as they got a little bit harder. So if I look at this, obviously I can pull out an x, but I look at 63 and 700, and neither one of those are going to be a perfect square. So I have to think, okay, what number can I pull out of both of these? So 9 times 7 is 63, and I have this 700. So I pulled out a 7. So 7 times 9 is 63, and 7 times 100 is 700. But this leaves me with a perfect square on the inside. So the 7x comes down, and I have 3x plus 10, 3x minus 10. All right? So over here, perfect square, subtraction. This one's pretty easy. Okay, 7 gets a little funky, so let's talk about 7. So what happens on number 7 is I've got all of these cubes in here. I have a cube here and I have a cube here, but this is not all cubes, so first step always is GCF. So I see I have one A that I can pull out, so I have that. And I have one B that I can pull out, so I have that. And I have one C that I can pull out. So now I have to see what's left. So if I go to my first term, if I took out 1, I need 3. I have 2 A's left. I got my B and I got my C, so I'm good. So subtraction, I go to my second one. I've got my A. I pulled out 1 B. I need 2 more, and I've got my C. So this is what I have. Now, this is a difference of squares. I know there's no numbers in there, so don't get jammed up on that, but this is squared and this is squared. So I have A plus B and A minus B. So I'm done. All right, so over here, I can pull out the 5, and I have x squared plus 4. And hopefully you saw this and you stopped here. This is not a difference. This is a sum. So because it's a sum, I can't go any farther. I'm all done. Okay, so if it was 5 times x squared minus 4, I could have kept going, but since it's plus 4, I have to stop. So always ask yourself those questions as you go through this. Okay, all right, we're going to do some in-class practice.